This is the fifth and final lecture from Chapter B. There's a section of your chapter with the heading Irregular Rhythmic and Metric Relationships, which starts on page 30. This section covers syncopation and hemiola, two important rhythm-related concepts. I explained syncopation in lecture 2 using Old Time Road as an example. You might want to refer back to that, and if you have questions, please let me know. Now, hemiola is a specific kind of syncopation. Hemiola involves a juxtaposition, or a sort of putting side by side, of a 2 grouping and a 3 grouping of either beats or divisions. Taking either beats or divisions, you'll have a going back and forth between having 3 of them grouped, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2. So going back and forth between 3 and 2, doesn't matter which one is first. So if you're in a compound meter with a dotted quarter beat divided into 3/8 notes, the music may briefly go into a simple meter with the 8th note divisions now grouped in pairs. This is famously what happens in Leonard Bernstein's song, America, from West Side Story. That's the song that goes, I like to live in America, da 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 da. An example B.10b shows you the rhythm of this. Each measure is based on a steady 8th note pulse. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But in the first and third measures, they're grouped according to the meter signature 6/8, so that you hear a 3 plus 3. I like to live in a. And then when we get to beat 2, the pulses are grouped by 2. America. I like to live in America. Da, 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 da. That is hemiola. It's hemiola whether you keep the meter signature in 6/8, as in the top line, or whether you actually renotate it and show an alternation between the 6/8 and the 3/4 rhythm. Example B.10c is another more complicated example of hemiola. And this time, instead of the 3 and 2 juxtaposition having to do with the divisions, the 3 and the 2 groupings have to do with the beat value. The music is in 3/4, and once we get a little farther into the piece, it's very clear that it's in 3/4. However, right at the beginning, as we listen to this music, it's not going to so much sound like it's in 3/4 as it's going to sound like it's in 3/2. Listen to what this melody sounds like. When you listen to it, right in the very first measure, you're going to hear 3 notes that are essentially a half note long. The third one is only a half note long if you add the next 8th note to it. But we're going, even though it's written as 1, 2, 3, 1, 2, 3, we're going to hear it more as 1 and 2 and 3 and. In other words, it sounds the way that it's written here on the lower line. Ordinarily, a meter of 3/4 would group 3 quarter notes in every measure. But the way that we hear the opening of this, it sounds like we're grouping 2 quarter notes into larger beat values. So that's another example of hemiola. Next, I want to say something about rhythmic notation. The last topic that's covered in Chapter B is the important topic of how to correctly write music in different meters so that the meter is clear and the music is easy to read. This is particularly important for instrumental music. If you're writing for band, or you're writing for orchestra, or for that matter, if you're writing for instrumental chamber music, you want the players to be able to easily sight read the music. Sight reading the rhythms is a big part of this. Now, there are 2 basic principles to good metric notation. The first principle, which is the most important, has to do with beaming. The second principle, which is somewhat less important, but still good to know, has to do with how to treat long notes that spill over and take up part of one beat and part of the next beat. So the first principle that has to do with beaming is this. Eighth notes and smaller durations should be beamed together in such a way that you show the beat. If the quarter note is the beat, you should beam pairs of eighth notes or groups of 4/16 notes and so on. If the dotted quarter is the beat, then you should beam eighth notes in groups of 3. So let's look at example B.12c, which has a few examples. In the top example, we see a correct way to use beams for these short notes. We're in 3/4. There should be 3 beats per measure, each beat being the length of a quarter note. This beaming shows us exactly where the beats are. It makes it really clear how to fit these notes into a 3-beat measure. If your conductor is on the podium and is directing your ensemble, 1, 2, 3, 1, 2, 3, you can watch her and you can easily sight read the music because it's very clear in the measure when you're in beat 1, when you're in beat 2, and when you're in beat 3. This is a wrong way of beaming the notes. In the first measure, you have 3 groups, but they no longer correspond to where the actual beats are. You have a short first beat and a long third beat, and the 4/16 notes are shown as if they're all the second beat, which is incorrect. The last measure, the beaming is all wrong for any kind of a triple meter. Take a look down here at the 6/8 measure. In 6/8 time, you still have the equivalent of 3 quarter notes or 6/8 per measure, but now the beat is the dotted quarter note. So the correct way to show this meter is to beam the 8th notes and 16th notes into groups that are equivalent to or that add up to a dotted quarter note. Ta, 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 ta. This is an incorrect way to beam the notes. It confuses our perception of the meter. And this is also an incorrect way of beaming the notes. This would be correct if we were in 3/4, but we're not in 3/4. 2 bullet points here to pay attention to. Even though it's common to beam groups of 4/8 notes in 4/4 time or common time, it's really better not to because it makes it look like cut time. Second bullet point, in very short measures, such as 3/8, 4/8, 2/4, it is acceptable to beam the whole measure together, and you often see that. The second principle of showing the meter clearly is this. If the midpoint of a measure comes in the middle of a long duration, or relatively long duration, it's better to break that long note into 2 tied durations so that the exact midpoint of the measure is visible. Take a look down here at the middle line, which is in 2/2 time. In the first measure, our rhythm goes like this: 1 and 2 and 4 and. Da, 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 da. The middle note of the measure is relatively long. It's equivalent to a quarter note, but it's very confusing if you show it like this, the way that it's shown in the wrong half of the diagram. If you show that note as a quarter note, it's harder to sight read this and it's harder to tell where you are in the 2/2 meter. Instead, what's preferable is to actually show the 2/8 notes that make up the quarter note. Why? Because the first 8th note is part of the big beat 1. The second 8th note is part of the big beat 2. And when we show both halves of that note, it's much clearer how to relate this pattern to the big 1, 2, 1, 2 count. Ba, 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 ba. The same thing is true in the 6/8 example. Here in the second measure, there is a note that's equivalent to a quarter note, but it also is divided into 2/8 notes tied together so that we can see the midpoint of the measure and see where that big beat 2 comes. This notation of the same rhythm is not correct in a 6/8 rhythm, although it would be correct for 3/4. Now, if you don't have very many notes in a measure, for instance, if you were in 2/4, having a pattern like eighth quarter, eighth, eighth quarter, eighth would probably be fine. You wouldn't need to break that quarter note into 2/8 notes, and doing so might even be confusing. But if you're going to have a larger number of notes in a measure, it's definitely a good idea to show the midpoint of the measure. At this point, I've covered all of the material in Chapter B in these 5 lectures. You should now be prepared to do all of the assignments from the end of the chapter, Chapter B. I'll be going rather quickly over these problems in a 6th lecture next.